Let us learn the principle of conservation of angular momentum along with its examples. Principle of conservation of angular momentum. By definition, the principle of conservation of angular momentum states that angular momentum of a body remains constant when the external torque is 0. Let us write L is equal to I omega is equal to constant K. Otherwise, this can be written as I1 omega 1 is equal to I2 omega. If the moment of inertia of a body is lowered, the angular velocity of a body omega increases. Let us prove this with an illustration. By definition, the rate of change of angular momentum is called torque. Tau is equal to dl by dt. If the torque is 0, then dl by dt also becomes 0. This can be written as angular momentum L is equal to constant. Since angular momentum is equal to constant, L1 becomes equal to L2. I1 omega 1 is equal to I2 omega. When a man with stretched out arms stands on a turntable which is revolving, then his moment of inertia is high. If he folded his hands, the moment of inertia decreases and hence the angular velocity, linear velocity increase, but the time period decreases. In both cases, angular momentum remains constant. An acrobat from a swing in a circus leaves the swing with certain angular momentum with his arms and legs stretched. As soon as he leaves the swing, he pulls his hands and legs together, thus lowering his moment of inertia and increasing his angular velocity. He then quickly makes somersaults in air and finally lands on a net or ground.